Hi, good morning, class. So it's Sir Capistrana again. For today, we will be looking into our lecture 3, which is Alkanes and Cycloalkanes. So for this lecture, we will be talking about the physical properties of alkanes, how would look alkanes would look like. We're actually done with the nomenclature of alkane, so we will be jumping into the reaction mechanisms of alkane. So again, we'll be talking about physical properties of alkanes. Then we will be jumping into the reaction mechanisms. So in that, let's first introduce alkanes and cycloalkanes. By alkanes and cycloalkanes, there's uh, organic compounds contain only carbon to carbon and carbon to hydrogen sigma bonds. By carbon to carbon and carbon to hydrogen sigma bonds are actually just the overlap between two atoms when they approach each other. So, for example, we have here the sigma bonds or sigma overlap or overlap regions of hydrogen to hydrogen, hydrogen to chlorine, and chlorine to chlorine. So this is how sigma bonds would look like. There is actually just a single bond wherein the sharing of due to the sharing of electrons, we will have here an overlap in between each of the atoms. For example, we have here this overlap for the hydrogen to hydrogen, this overlap for hydrogen chlorine, and this chlorine to chlorine overlap. And for alkanes and cycloalkanes, actually, this is not limited to alkanes and cycloalkanes. This is also true for the other functional groups or other organic compounds. All carbons are sp3 hybridized. As you may have remembered, this sp, this is actually our electron configuration that we have talked about during Chem Zero, wherein we talk about this under the Schrodinger wave equation. So by sp3 hybridization, as you may have remembered, carbon has four valence electrons. And those four valence electrons are actually 2s 2s1 and we have 3p3. So in that, as you may encounter, we have here this for this orbitals. Okay, so we have here the s, the px, the py, and the pz. So when we say that the those orbitals are sp3 hybridized, meaning to say magkakaroon tayo ng transformation ng ating orbitals from this circular orbital to this sp3. So, meaning to say, all of this, also the px, wherein we have here our region, yung region natin na to, it will be transformed into this one, okay? Also, that is the same for the py and the pz. So, all of those combined, we will have here a carbon, which is actually sp3 hybridized. So, we have here one s orbital and three p orbitals. Meaning to say, regarding the angles in which the orbitals or the sharing of electrons will happen or the bonds will happen, the angle of each bond will be 109.5. So, as you may have remembered, nung pinakita ko sa inyo last week, yung model natin in using yung using space filling method. Kung nakikita nyo, naka-angle yung mga hydrogen natin dun sa ating carbon in such a way na parang there are na yung layo nila sa isa't isa ay yung furthest. Okay? So that is kaya naging reason dun sa sp3 hybridization natin. Okay? So Also, for alkanes and cycloalkanes, here are some of the physical properties of alkanes and cycloalkanes. So these are non-polar compounds. So bakit sila non-polar? Due to being strictly uh, carbon and hydrogen on single bonds, you may expect that, ayun, walang site for partial charges. So, dahil dun sa walang site for partial charges, kung makikita nyo dito, yung buong paligid niya, lahat ay, we have here cyclohexane. For the cyclohexane, as you may see here, we have here, the surrounding is actually surrounded by what we call hydrogen. So, this being surrounded by hydrogen, walang site kung saan yung mas negative or mas positive. Therefore, walang poles. Wala tayong magiging partially positive or partially negative na side. Kaya, non-polar siya. Meaning to say, if we say non-polar, usually when we have, let's say, liquid na organic compound na alkanes, pag inihalo natin sila sa polar compounds like acetone, like water, hindi siya magi-emulsify or hindi emulsify. Hindi magiging miscible yung dalawang compound. By miscible, hindi sila maghahalo. Okay? Hindi sila magiging completely miscible. So in that, we also have here our physical property determined by London dispersion forces or yung tinatawag nating van der Waals forces. It also have a low boiling point. When we have a low boiling point, ibig sabihin, mataas din yung tinatawag nating tendency niya na maging gas. So you may have remembered, evaporation point is actually same with boiling point. And as being a nonpolar compound, it is insoluble in polar solvents like water. So let's talk more about this London dispersion forces. Kasi kung isipin nyo, ito yung pinaka magdedetermine nung dalawang sumunod na ay yung low boiling point natin. Kasi kung titingnan nyo dito, we have here our different alkanes. Mukha lang siyang ano no, mukha lang siyang lines pero actually this is one way of representing our alkanes or any other carbon compound. So for this compounds, paano natin to titingnan? So if we have here this one, this is actually propane. So paano naging propane siya? So for this notation, each endpoint of a segment is actually a carbon atom with hydrogen bonded to it. Meaning to say, for this for this propane, we have here carbon, first carbon, second carbon, and third carbon. Similar for this one. As you can see here, we have here 1 endpoint, 2, 3, 4. Meaning to say we have here 4 carbon here with hydrogens attached to it. Meaning to say this is butane. And for this one, we have 1, 2, 3, 4, 5. This is pentane. And 1, 2, 3, 4, 5, 6. We have here hexane. And as you can see here, habang pahaba ng pahaba yung chain, pataas ng pataas yung ating boiling point. Okay? We started with negative 42.1. As you can see here, profane is actually uh, always in gaseous form when in room temperature, which is 35 degrees Celsius. As you may have remembered, propane is actually a component of our LPG or liquefied petroleum gas. Same with butane. We have butane canister that is used for butane torches and also butane stoves. So as you can see here, we have here negative 0.5, which is actually gaseous din yung ating butane in room temperature. Also, for our pentane, medyo naglalaro dun sa dalawang yan, ano, kasi depende sa room temperature na pinag-uusapan. If we have a room temperature which is 35 degrees Celsius, uh, our pentane will be in liquid form. And for hexane, ito na yung pinaka, nag-a-appear as, tawag dito, nag-a-appear as in liquid form due to its boiling point. So as you can see here, increasing yung temperature or yung boiling point habang lumalaki or humahaba yung ating molecule. Same with the cyclic analogs of or the cycloalkanes. As you can see here, we have here cyclopropane, cyclobutane, cyclopentane, and cyclohexane. So bakit siya naging cyclopentane? Cyclic siya. Then we have here four carbon atoms. Bakit ito naging cyclobutane? Because we have here 1, 2, 3, 4 carbon atoms and in cyclic form siya. Paikot. So that is cyclobutane. Same with cyclopentane and cyclohexane. As you can see here, habang lumalaki din yung ring size or dumadami yung carbon atoms dun sa ating cycloalkanes, pataas din yung ating tinatawag na boiling point. Okay? And for the branching, we have here branching compounds or deep for ano. Kung titingnan natin, lahat ng nandito sa baba, actually all of them have 5 carbon atoms. So we have here 1, 2, 3, 4, 5. This is pentane. So we have here 1, 2, 3, 4, 5. In common name, this is actually also pentane. So this is isopentane, as you may have remembered. And we have here 1, 2, 3, 4, 5. This is neopentane. Pero kung bibigyan natin yung IUPAC name, this will be pentane. This will be 2-methyl 2-methyl butane, and we have here a 2,2-dimethyl profane. Okay. As you can see here, we have here decreasing naman. Habang parami ng parami yung branches, so we have here one branch. So from 36.1, it became 28 degrees Celsius ang boiling point. And we have here two branches. So we have here, for those two branches, we have here 9.5. So sir, ano naman po ang connection yung boiling point na yan dyan sa London Dispersion Forces? So basically, actually class, boiling point is just one of our indicators regarding what we call the intermolecular forces of attraction between molecules. Meaning to say, kapag mas malaki or mas malakas yung tinatawag nating interaction or bonding or kumbaga intramolecular bonding ng molecules natin, mas tumataas yung boiling point natin. Meaning to say, for these examples actually, pataas yung tinatawag natin or for these bond lengths, kung titingnan natin, or chain lengths, as we go along this lengths, tumataas actually yung tinatawag nating London Dispersion Forces or van der Waals forces of attraction. So, same with this, and not same with this. Habang dumadami naman yung branching, nagiging mas mababa yung London Dispersion Forces. So, para mas ma-visualize natin, gamitin natin ulit yung ating model na ginamit natin last week. Hello. So, okay. So, class, we have here our example earlier. This is actually pentane, profane pala, sorry, not pentane. So, for pentane, profane, as you can see here, we have here 3 carbon atoms and we have 8 hydrogen atoms. So, for the van der Waals, mas makikita natin yung distinction. Ito kanina yung negative 40 something lang. yung ating boiling point. So, i-compare natin siya sa isang mas malaking or mas mahabang molecule. So, para dun sa mas mahabang molecule, we have here our pentane. So, pentane have five carbon atoms, and we have here three, 5, 7, 9, plus 3. We have 12 hydrogen atoms. So, anong difference nung pentane dun sa propane? Okay. So, kung titingnan natin actually, ang van der Waals actually ay nakadepende sa ating tinatawag na surface area. Okay. So, by surface area, ang ibig lang nating sabihin dyan, kung titingnan natin kung ngayon, babalik tayo ngayon dito sa propane, kung ang propane ay mag interact sa iba pang propane, less yung contact points natin na sinatawag. Ano? Kasi by van der Waals or London Dispersion Forces, this intermolecular force of attraction is dependent to the contact points, but basically surface area. Meaning to say, if we have here a smaller molecule like this one, this profane, this actually is have a lower surface area in comparison with our pentane. Kasi kung titingnan natin dito sa pentane natin, there is actually a lot of contact points for this compound. So, dyan, ganun din yung basics regarding or yung idea regarding dun sa ating mga cyclic analogs. So, for the cyclopropane, it has lower, smaller contact points in comparison with butane, with cyclopropane, cyclobutane, cyclopentane, and cyclohexane. So, based on that, if we have lower chain length or smaller ring size when it comes to alkanes, that only depends upon London dispersion forces for the interaction. I-expect natin na mas mababa talaga yung yung boiling points nila. Ibig sabihin, mas mabilis silang mag-disperse o mas mabilis silang mag-turn into gaseous form. Meaning to say, kung ang stability na tinitingnan natin ay hindi siya go into chaos by chaos ay in gaseous form, mas stable yung ating mga cycloalkanes na mas mataas yung molecule size at saka yung ring size. So, paano naman yung uh, dun sa branching? Kung titingnan natin kanina, when it comes to pentane, ito yung surface area niya. Tama ba? So, yan yung tinitingnan natin kanina. Surface area ng pentane ay ganyan. So, bakit nung nagkaroon ng branching, mas naging konti yung contact points na tinatawag natin? So, pakita lang natin. So, let's have this isopentane. So, for isopentane, as you can see here, class, pakita ko muna dito sa side na to. Ito yung isang side. Kung titingnan nyo actually siya class, merong indention na nangyayari. Merong bending due to, as you can see here, this is one of the sides. As you can see here, merong matatagong mga areas dito sa ating dito sa ating isopentane. Ano? Dahil dun sa overlap ng areas or dahil dun sa mga areas na to, kasi actually kung ikot-ikutin natin yan, single bond kasi siya eh. So, possible yung rotation, yung bond rotation natin. So, kahit anong ikot ko dyan, nagkakaroon ng area na hindi natin na-access. Kumbaga, or kung titingnan natin yung surface area nung molecule natin, mas lumiit siya in comparison with our pentane. So this is just isopentane. So paano pa yung tinatawag nating neopentane? So for neopentane, kung titingnan nyo actually, kung i-compare nyo yung, nasaan na yung kulang kanina? Yan. So, kung i-compare nyo dun sa isopentane, mas maraming areas na dito ang hindi covered. Kasi kung titingnan nyo, from lima na kita or lima na pwedeng ma-access for surface area for interaction, meron tayong isang molecule dito sa gitna. Itong carbon compound natin dito na uh, na hindi na mako-cover or hindi na magkakaroon ng tinatawag nating interaction or contact point sa iba pang neopentane. So that is the reason why as we increase the number of branching for our alkanes, bumababa yung tinatawag nating boiling point. Meaning to say, bumababa yung interaction or less yung strength ng interaction between each molecule of the neopentane. So hopefully that's clear. So moving on with our lesson. So in that class, hopefully malinaw na yung distinction or malinaw na yung reason kung bakit ganito yung trend na tinatawag natin. So, remind ko lang yung trend. Para dun sa chain length or for the chain length, again, so for the chain length, as the length or the length of the chain increases, pataas din yung ating London Dispersion Forces, meaning to say, pataas din yung ating boiling point and some other concepts regarding or some other properties that is related to intermolecular forces of attraction. Again, that is the same for the ring size. As the ring size increases, the London Dispersion Forces also increases. Meaning to say, boiling point increases, specific gravity and the like increases. And for the chain branching, as the chain or the branching increases or the number of branches increases in a compound, for compounds or organic compounds or alkane having the same number of carbon atoms, the London dispersion forces decreases due to the decrease in the surface area or the contact points of the molecules. Therefore, as the number of chain or chain branching increases, the the London dispersion forces decreases and the boiling point and other property decreases. So in that, let's discuss another property of carbon atoms. Not this is not specific to alkanes. We have here the types or classification of carbon atoms. So for the classification of carbon atoms, we have here actually what we call the primary, the secondary, tertiary, and the quaternary carbon atoms. So paano natin madi-distinguish yun? So in that actually, for the classification of carbon, it is based on the number of atoms to which they are attached. Okay. So for this one, let's focus on the central carbon. This is actually what we call a primary carbon atom. So by primary carbon atom, bakit siya naging primary? Because if we look into the number of carbons that is attached to this carbon, we only have one carbon. So that is why it is called a primary carbon. So for this next example, as you may see here, we have here two carbons that is attached to this carbon. Okay? So basically, this is what we call our secondary carbon atom. Okay? So for the next one, hopefully nakukuha nyo na yung pattern. For this one, we have here three carbon atoms that is attached to this central carbon. Okay? Making this central carbon our tertiary carbon. Okay? And for this one, as you can see here, we have here four carbon atoms that is attached to this central carbon atom. Meaning to say, this will be our quaternary or the fourth degree carbon atom. So for our hydrogen atoms, the basis for classification of carbon hydrogen atoms is actually based on the type of carbon atoms that to which they are attached. So, for example, for this first carbon, since this carbon is a primary carbon, meaning to say all of the hydrogens that is attached to this carbon will be a primary hydrogen. So, for this one, we have here a secondary carbon, meaning to say these hydrogens are secondary carbon. And for this third one, we have here a tertiary carbon. So we have here a hydrogen that is attached to a tertiary carbon. So we have here a tertiary hydrogen. So as you can see here, there is no such thing as quaternary hydrogen. So we only have primary, secondary, and tertiary hydrogen. So bakit? As you can see here for our quaternary carbon, makikita natin dito na wala na kasing hydrogen or wala nang sites for the bonding of hydrogen, meaning to say, wala tayong tinatawag na quaternary hydrogen. Okay. So, in that, hopefully nakuha nyo yung yung basis natin on how to classify carbon atoms. So, in that, we will be moving for the next video. I will be discussing the reaction mechanisms, or the next part of the video. We will be discussing the reaction mechanisms of alkanes and cycloalkanes. Alright, class. So again, this is the part where we will be looking into the reactions of alkanes and cycloalkanes. As you may have remembered on our past discussion regarding functional groups, alkane is somewhat special because of that the non-existence of functional group of alkanes. By non-existence of functional groups, as you may have remembered, functional groups are actually the sites for reaction or reaction sites tinatawag natin. So, without these reaction sites, the number or the types of reaction that can exist regarding alkanes and cycloalkanes are actually limited. In that, combustion and halogenation are the chief reactions that undergone by not undergone undergone by alkanes and cycloalkanes. So all of this actually proceed via what we call free radical mechanisms. This is due to the existence of heat and or high temperature or light in which the reaction proceeds due to the excess in energy, or what we call the condition for the reaction. So in this, we have actually five types of reactions involving alkanes. We have here complete combustion of alkanes. We also have the complete combustion of cycloalkanes. And also we have the incomplete combustion of alkanes and cycloalkanes. Also, we have the halogenation, or to be specific, monohalogenation for this discussion. And also we have what we call ring opening of cyclopropane. So for the first reaction, we have here the three combustion reactions. Or in first, let's discuss complete combustion of alkanes. So via definition of combustion, this is just burning per se. We introduce oxygen to our organic compound, and with that oxygen, we will using spark or flame, we will combust the organic compound, for this example alkanes, to produce carbon dioxide, water, and heat. So in this, actually, we have a structured formula, or say, for an equation in which we can determine how many moles of carbon dioxide can we produce for a certain type of, let's say, organic compound. So for example, if we have, say, we have, let's use ethane. So ethane is no, not 3. That is C2H8. Tama ba? No. It's C2H6. Sorry about that. So we have there C2H6, which is our ethane. So if we are to combust this ethane, as the formula entails, we need 3N plus 1 over 2 amounts or moles of oxygen. So in that, if we have 2 as our number of carbon atoms here, so we will be using 2 for this N. So we will have 3 times 2 plus 1 over 2. Then we have oxygen. And with spark, we will produce N numbers or N moles of carbon dioxide. So we have there N is 2. So we have 2 moles of carbon dioxide plus N plus 1 of water, N being 2. So we will have it here 2 plus 1 moles of water. So for the heat, we will not quantify heat in this example because it may complicate things. But for this example, simplifying all of this, we will have C2H6 plus 7 over 2. That is 6 plus 1 over 2. So 7 over 2 oxygen. Not Q. We have here oxygen uh, using spark will produce 2 moles of carbon dioxide plus 3 moles of water and, of course, heat. So as you can see here, this reaction is actually exothermic, meaning to say the reaction will produce heat or the heat will come from the substrate and not onto the substrate. Okay, in this, we can further simplify this because alam ko naman, ayaw na ayaw niyo ng fraction. So to remove this, we can actually just multiply 2 to all of the molecules here. So we will have 2 C2H6. We don't uh, we don't alter the subscripts here. So we have here plus 7 moles of oxygen, spark. My spark now. Then we have 4 CO2 plus times 2, that's 6 H2O. And again, we will not be quantifying. Okay? So that is the complete combustion of alkanes. So the same goes for cycloalkanes. So for cycloalkanes, we will also use this formula. So if we have, let's say, cyclopropane, because we cannot have cyclomethane or cycloethane. If for cyclopropane, we have C3H6, right? Then again, just applying the formula, N will be the number of carbon atoms. So we will have here 3 times 3, 3 times 3 over 2. So that will be how many moles of our oxygen. Same, instead of spark, we will use flame. So for the flame, we have N, which is 3. And we have CO2 plus 3 moles of water. And also, let's not forget the heat. Okay. So again, we can further simplify this. So we have uh, this will be 9 over 2. So we will have multiply 2 again. So we have 2C3H6 plus 9 oxygen. And we have here our condition, which is flame. And times 2, we have here 6 moles of carbon dioxide plus, again, 6 moles of water, and also not quantifying the heat. Alright. So that is an example of a complete combustion of cycloalkane, and for our example, we used uh, our cyclopropane. Anyway, in this, we also have what we call the incomplete combustion. So, saan ba nagre-rely yung tinatawag nating incomplete, yung combustion, ano? So, kung makikita niya kanina, mula nung sa ano natin, sa first example natin, which is yung ano, yung sa alkanes, at saka din sa cycloalkanes, we actually quantified the amount of oxygen or the number of moles of oxygen required for the reaction to proceed or uh, to completely combust our methane, our alkane. So, when it comes to incomplete combustion happens when there is not enough oxygen gas for the combustion. Meaning to say, kulang yung oxygen para completely na yung lahat ng ano natin, nung organic compound natin, ay ma-transform natin sa CO2. So in this, we don't have a way to provide an equation or a balanced chemical equation for incomplete combustion due to the presence of probability or variability regarding how much carbon dioxide and carbon monoxide and carbon we will be producing. So in that, ano ba yung mga sinasabi nating pwedeng example ng incomplete combustion? So, as you may think, pwede kasi itong mangyari. Halimbawa, nagsunog ka ng damo, though hindi talaga strictly alkane lang yung nasa damo. Kung mapapansin natin, merong mga gases na pwedeng lumabas doon. Yung dark na gas na nakikita natin doon ay pwedeng yung ating carbon monoxide and also andun din yung ating carbon dioxide. So saan natin makikita tong carbon? As you may notice, sometimes if we look into yung sinunog natin, may natitirang abo or yung black na na residue. That is actually mainly carbon. So that is the part where you can spot or you can see carbon. And due to the presence of variability regarding kung gaano karami yung carbon dioxide na napoproduce, yung carbon monoxide na napoproduce, at yung carbon na napoproduce, we cannot actually quantify yung or we cannot provide a complete and balanced chemical equation for incomplete combustion of alkanes and cycloalkanes. So in that, we have the three combustion reactions of alkanes. So hopefully, by this time, nakakasunod pa rin kayo. And hopefully, kung may questions kayo, ayun, same as always. Don't hesitate to contact me. Alright. So uh, for the fourth reaction or for the fourth reaction mechanism involving alkanes, we have what we call halogenation. By halogenation, it is just a replacement of hydrogen atoms of a CH bond with a halogen. And this reaction is called halogenation, which is actually a free radical substitution reaction which occurs upon exposure to light, sometimes UV, or high temperature. Okay? So basically, if we have halogenation, if we have an R group, right? Siyempre, yung R group natin, yung nakabond siya sa, sa hydrogen natin, knowing that this reaction happens for alkane, and we expose them to uh, halogen, let's say here XX, and we expose this substrate and reactant to light or heat, we will have here our alkyl halide and our hydrogen halide. So in that, monohalogenation of alkanes and cycloalkanes usually yield a mixture of isomeric products. By isomeric products, we will see in the example later. So it depends on the number of sets of equivalent hydrogen atoms in the molecule. So para muna makita natin kung ano yung mangyayari dun sa monohalogenation mismo, let's look into what we call the chain reaction of involving monohalogenation. But basically, this is just a free radical substitution mechanism. Okay. So, ang free radical substitution mechanism, merong tatlong parts. So, we have the CIS, we have the CPS, and also we have the CTS. So, ano ba yung mga yan? So, C, all of this C actually stands for chain. Okay? And I stands for initiating, pagsisimula. P is propagating, pagpapatuloy. And T is for terminating or pagtapos. And S stands for steps. Step. So, basically, in free radical substitution mechanism, we have these three steps. So, we have the chain initiating, chain propagating, and chain terminating step. So, to do this, let's use an example wherein we will be using the simplest alkane, which is the methane. So, if we have methane and we react that methane to a certain uh, halogen, say X2, okay? And we expose that to UV light or high temperature, kung ano man yung ginamit natin. So, this will actually produce what we call C3X or monohalomethane, or we can call this monomethyl halide. And also, we will have here our hydrogen halide. Okay. So, ano ba yung steps by step na nangyayari? Due to the presence of UV, nagkakaroon actually tayo, yung first step na nangyayari is we have here what we call our bond cleavages. You may have remembered, if we have here X2, they are actually bonded or single bonded uh, or a covalent bond. We have here a covalent bond wherein we will have here our bond cleavage wherein each of this atom will have one one lone electron. Okay? So that is why we call them free radical. That is because of the presence of our UV here. So basically, we will have here free radical halogens or two free radical halides. Okay? So in that, uh, dahil dun sa presence ng halide na yan, we will have here the cleaving of H3C and our hydrogen. Both will have one electron. Okay? Therefore, we will be having what we call kulang dito. This is due to the presence of one free radical. Dahil dyan, we will have here our H3C free radical plus our hydrogen halide. But the reaction doesn't stop there. As you may have remembered, we have here other other free radicals. Due to that, itong ating methyl free radical, it will attack other molecules of our halides or halogen. So Therefore, magtutuloy yung process na magkakaroon tayo ng cleaving of covalent bonds. Therefore, we will have here H our monohalomethane. And we have here H3C that is bonded to halogen plus magkakaroon tayo dito ng another free radical. Okay? And magtutuloy lang yun yung ibang free radical, as you can see here, meron tayong libre dito kanina. Tapos meron tayong libre dito. We will have here bonding of this free radicals wherein they will bond to each other, therefore forming what we call our halogen. And also, some of it will be bonded to other free radical of our metal, therefore forming what we call our mono halometal. And also, for the last step, some of the metal free radical will actually bond with other free radical metal. So therefore, forming our ethane here. Okay. So that is actually the last part of the reaction. So here's the full free radical substitution mechanisms involving methane. So as you can see here, meron tayong apat na lumabas dun sa reaction. Pero actually yung pinapakita lang natin usually ay yung sa metal halide. Pero as you can see here, we have here excess halides. We have here our monohalo methyl, methane pala. Then also we have here our methane, and also we have here our hydrogen halide. So, as you can see here, ang daming naging byproducts ng reaction. But basically, all of this follow the mechanism of chain initiating, chain propagating, and chain terminating. So, saan nagsimula yung chain initiating? It started here. This is our chain initiating step. Wherein due to the presence of UV light or UV, we have here the production of our uh, halogen free radicals. And due to the presence of halogen free radicals, nagkaroon tayo ng cleaving ng bond between our carbon and hydrogen here, forming our metal free radicals. So kaya yon nagtuloy-tuloy. By nagtuloy-tuloy, these two steps are what we call the CPS or the chain propagating step. Dahil dyan sa step na yan, nagtuloy-tuloy yung reaction, tuloy-tuloy na nagkaroon ng ating mga halogen free radicals at saka yung ating metal free radicals. And these three steps are actually what we call the chain terminating steps. By chain terminating steps, dahil nag-reverse na or bumalik na sa pagiging halogen yung iba nating halogen, free radicals, nagkaroon na rin tayo ng tinatawag nating monohalomethane, itong ikalawa, itong nasa step 5. And also, we have here our ethane. So dahil dyan sa production na to, mag-stop na yung reaction. Therefore, that's what we call them terminating. So dyan mag-end yung ating reaction. Wherein this ethane is actually considered as our side product. Or kumbaga, sa gamot, side effect yun yan. So yan yung mga natin, yung chain reaction mechanisms natin. At yan class, kung titingnan nyo, ay nangyari lang sa isang carbon to hydrogen bond lang. Yes. Sa isang carbon lang yan. So, how about this ones? So, as you can see here, we have here, dito muna tayo sa ating 2-methyl butane. So, bakit nga siya 2-methyl butane? Sabi ko kanina, if we have here 1, 2, 3, 4, 5, kung yung 5 na yan ay endpoints, that means we have their carbons. And for those carbons, if we have here a tertiary carbon, this one, ibig sabihin, meron dyang isang hydrogen. We have here a primary carbon. Ibig sabihin, we have here tatlong hydrogen. Also for this one, we have here 3 hydrogen. For this one, this is actually a secondary carbon. Meaning to say, we have here dalawang hydrogen atoms na nakabond sa kanya. And for this one, we have here 3 hydrogen. Kasi primary din siya. And kung titingnan nyo, ang sabi lang sa atin sa monohalogenation, if we add a halogen in this chemical, ano lang mangyayari? Or this organic compound, ano mangyayari? Magkakaroon tayo ng cleaving ng bond nung sa H3 or dun sa C at saka sa H. So, aling H? Yung bang nasa tertiary natin? Yung bang nasa secondary? Or yung mga nandun sa primary? Same for this one. As you can see here, we have here isang primary. Ibig sabihin, tatlong hydrogen ulit. Again, we have here another primary carbon. Ibig sabihin, tatlong carbons, tatlong hydrogen ulit yan. Again, we have here a secondary carbon and another secondary carbon, another tertiary carbon, and another primary carbon. For this one siguro, hindi tayo problema. Bakit? Kasi, this one being a quaternary carbon, kasi apat na carbon yung nakakabit sa kanila, or for this one, 1, 2, for this one, we have 1, 2, 3, and this is the fourth one. Okay, for this one, we have 1, this one, this one, this one, and this one. So, yung dalawang quaternary na yan, wala silang walang hydrogen dyan. So, wala tayong magiging problema dyan. Kaso, we have here a primary carbon, another primary carbon, another primary carbon, another primary carbon, and another primary carbon. Hindi tayo masyadong mga problema dito kasi puro primary sila. Kasi, and kung nakita nyo kanina, kung pag umikot yung mga bonds natin, halos pare-parehas lang naman magiging itsura niyan. But, saan dyan? So, another thing, we have here this one. We have here a Pentane, and we have here a methyl. So this is 1-methyl cyclopentane. So for this one, again, we have here a secondary carbon. We have here a primary carbon, secondary, tertiary carbon. So knowing that, paano magpo-proceed yung reaction? Anong mangyayari? I mean, saan ba talaga sila kakabit? Or saan makikipagpalit yung halogens natin? So, dyan, actually, meron tayong sagot. Yun actually ay nakadepende kung anong halogen ang gagamitin natin. So, the rate, relative proportion of isomeric products depends on the rate of abstraction of hydrogen atom in a given halogen reagent. Also, probability factor or the number of equivalent hydrogen atoms are isa pang pwede nating tingnan. Wherein in chlorinization or pag-add ng tinatawag nating chlorine, it is not selective. So, ito yung rates niya. So, we have here 5 these ratios. And for bromination, ito yung medyo selective, meaning, ibig sabihin, mas pipiliin niya yung tertiary kaysa sa secondary at sa primary. So basically, kung titingnan natin yung mga examples natin kanina. So if we have here the first one, this one, our 1-methyl 1-methyl butane. For this one, majority of our products, ulitin ko ha, majority of the product of halogenation will act kapag bromination ang susundin natin, halos lahat ng bromine ay ito ang i-break. Pero may tendency rin na pwedeng ang kunin niya is either of these two secondary hydrogen, pero mababa yung chance na magbabond siya rito sa mga primary. Same for this one. So if we have bromine or we will be using bromine, karamihan ng magiging products natin ay dito sila magbabond sa carbon na to. Kasi ito yung mayroong tertiary hydrogen. Okay? So for this one, since lahat ito ay primary, ibig sabihin, our primary carbons yung nakapaligid, at lahat ng makakabit sa kanila ay primary hydrogen, so pwedeng kahit saan doon sa mga sa ano na yan, sa 3, 6, 9, 12, 15, 18 na hydrogen dyan ang pwedeng mag-bond yung ating bromine or yung chlorine. So for this one, for this nasa dulo, itong ating 1-methyl cyclopentane. For this one, ang mangyayari lang dito actually ay karamihan ay dito magbabond sa carbon na to kasi siya yung tertiary carbon, ibig sabihin siya yung may tertiary hydrogen. Okay. Pero kapag chlorine, it is very likely na halos magsising dami or by magsising dami, halos pantay-pantay yung proportion kasi kung titingnan nyo, in comparison with bromination, we only have 5, 3.8, and 1. Hindi masyadong malaki yung bias, kumbaga. So kapag chlorine, may tendency na marami pa rin magbabond dun sa mga primary at dun sa secondary kapag i-compare na natin siya ron sa ating tertiary carbon. Okay. So, yan ang ating monohalogenation. Okay. So, hopefully, medyo nakakasunod pa kayo, ano? So, but anyway, we will be looking more into this as we discuss other types of halogenation when it comes to 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 alkenes. But for now, balikan lang muna natin ulit ng mga example na to. So, ayun, yung mga structures na pwede nating makuha para dun muna sa ating methyl butane, we can have, ito pala, 2. Sorry. This should be 2 methyl butane. So, we have here, kung ang i-add natin ay, say, bromine. So, for bromine, ang mga possible na, ano natin, na isomers natin, it will be 1 bromyl dash 2 methyl butane. Pwede nyong i-drawing para malaman nyo kung anong itsura nitong 1 bromyl 2 methyl butane. We can also have 2 bromyl, medyo iangat ko class 2 bromyl 2 methyl butane. Also, we can have we have 2 bromyl 3 methyl butane. Also, we can have 1 bromyl 3 methyl butane. So, yan yung mga pwedeng maging itsura natin dyan. So, for the second one, pwede nyo actually hatiin to kung titingnan nyo kasi ito ay symmetrical. So, ang mga Pwedeng maging ano natin dito, pag bromide ang i-add natin, eh pwede rito sa primary na to, secondary na to, tertiary na to, sa primary na to. Same na yon, magka-count na yon with isomers dito sa kabila. Ibig sabihin, mirror images lang naman sila. So kapag nag-bond ulit kayo dito sa kabila, same with itsura nitong nandito. And for this one, you just, since ito ay symmetrical dito, you can actually just name just two of them or just one of them. And for this one, you can actually name using this one, this tertiary, secondary, and this secondary. So, and next time we will just look into the meaning of isomers para maintindihan yung mga pinagdi-discuss natin dito for now. Okay. So for the last reaction of alkanes and cycloalkanes, we actually have here the reactions of cyclopropane. So by cyclopropane, this mainly are ring opening reactions of cyclopropane. Uh, in here is we have here our conditions or our reagents. Nickel here is the catalyst. Hydrogen here is the reagent. HCl here is a reagent. HBr is a reagent. Cl2 here will be the reagent, and iron 3 chloride will be our catalyst. So for in here, we have here bromine will be our reagent, and F our iron 3 bromide will be our catalyst. So by ring opening, ang ibig lang sabihin niyan, bumubukas yung ring. So, paano ba bumubukas yung ring? So, pakita lang natin kung ano ba bakit bumubukas yung ring. Ano nangyayari? Bakit hindi na lang nag-a-add dun sa hydrogen or nagkakaroon ng substitution dun sa hydrogen? Basically, all of this are free radical substitution. But, imbis na substitution na nangyayari, nagkakaroon tayo ng, ng free radicals. Nagiging free radical yung ating cyclopropane due to the existence of what we call stress or ring stress or angle stress. So, pakita natin kung anong itsura na. So, okay. Okay, class. So, basically, babalikan natin kanina yung description na binigay natin kanina sa carbon. Wherein, if we have here a carbon compound, so for our carbon compound, as you may see here, there is a certain angle wherein kung paano nakapwesto yung mga bonds dun sa ating carbon. So, in that, if we have here our, we have here our propane. So, makikita nyo, if we consider a bond or yung, yung sharing ng electron as a straight line, okay, straight, nice and straight, tama ba? So, if we actually make this a cyclic analog, as you may see here, again, I just removed two hydrogens here because of being cyclic analogs. So, watch what will happen. I just attach this one at the bottom of the one of the carbons, and if we attach that just following the same location for bonding of our carbon, as you can see here, we have here a bend dun sa ating bonds, ng ating carbons. That is actually what we call ring or angle stress. And due to the presence of that ring or angle stress, hindi ganun ka-stable yung ating cyclopropane. Hindi katulad ng ating higher cyclic analogs like butane, which forms a square. Medyo may bend yung ating sa butane, pero hindi ganito ka-stress. Okay? So in here, as you can see here, due to this bend, merong certain stress na nangyayari dyan. At dahil dun sa stress na yun, in the presence of, let's say, free radicals, madaling ma-break yung bond na yan. And those bonds will actually be free radicals kasi two-way yung cleaving ng bonds na yan. At dahil dun sa two-way of breaking ng bonds na yan, meron tayong magiging sites for addition or substitution or addition ng, for this case. So, kaya tayo meron nung sa limang reactions na yon with hydrogen, with HCl, with HBr, with chlorine in the presence of iron 3 chloride, and bromine in the presence of iron 3 bromide. Okay? So that is why ring opening of reactions of cyclohexane is somehow special in that regard. Okay, so going back to our slides. So in that, kaya dahil dun sa stress or sa ring strain na sinasabi natin, so, cyclopropane being the one or the cyclic analog with the highest ring strain among cycloalkanes, nagkakaroon tayo ng tinatawag nating breaking ng bond na yon. Kaya tayo nagkakaroon ng ring opening, which would result to the relief, kumbaga, somehow ma-reach niya yung stability na tinatawag natin. Kaya nag-open yung rings nila. Okay? So in that, we have there the reactions of alkanes and cycloalkanes. So in this, just a review, in this video we have discussed the properties of alkanes. We also discussed the hybridization of carbons and also the reactions of our alkanes and cycloalkanes. So that will be all for today. There will be no exercises or pieces for now because I know that I have given you a lot of exercise to do. So in that, have a nice day. Bye bye.